Hey guys, welcome back to our VCP 6.5 ICM hands-on training. This is the lab 19 and this is the part 2 of our lab 19, which is vSphere HA. In this lab, we will go ahead and continue working with the vSphere HA. We will go ahead and work with the admission control. And to work with the admission control, we will go ahead and start making use of the slot size. Think of the admission control as a way to ensure that we always have sufficient resources available in a cluster in case if there is a failover happens, because we want to make sure the failover cluster has enough capacity in case one of your ESXi host or multiple ESXi host fails. That's the time this resource revision or the admission control really comes handy, and we can go ahead and make use of a slot size to calculate or to do some of the calculation in terms of the capacity for our cluster. Now let's go ahead and jump directly back to our vSphere web client, and we had created this HA cluster. If I come back to HA cluster, as you can see in the previous lab we had rebooted. After reboot, 44 came back and we are into the monitor vSphere HA. Right now summary, if you take a look at summary, it shows the master is right now 45 and there are two virtual machines being protected because I have two VMs powered on right now, 3 and 5, and there is one host connected to this particular cluster. Now let's go ahead and work with the admission control, and for that we'll go ahead and change some of the settings, or we'll go ahead and enable the admission control. So for that we can just simply come back to our HA cluster, and then from the HA cluster we can just simply go ahead and right click here, and within that option we have something called the settings. So just simply go to the settings, which is nothing but again the configure. So we could have just simply clicked on the configure here. Now within this page we will go ahead and scroll down to something called your admission control. So now let's go ahead and take a look in terms of the admission control. Now go ahead and click on vSphere availability. Within the vSphere availability, there are a couple of options that says vSphere HA is right now being turned on. That's what we had enabled. We are monitoring for host failure and respond. In the case the response is restart VM, that means we will go ahead and migrate those VMs from the failed host to our one of the working host right now. So just simply go ahead and click edit on this page, and when we go ahead and edit, we are editing the cluster setting. So on this page there are a couple of the options. If you take a look on the left hand side, there's a failure and responses, proactive HA failure and responses, and there is an option that says admission control. Now if we go ahead and quickly read about the admission control, is a policy used by HA to ensure failover capacity within a cluster. Increasing the value of host failure cluster tolerates will increase the availability constraint and capacity reserve. So this is a place where we can go ahead and configure some of the settings here. So host failure cluster tolerate one maximum in one less than number of hosts in cluster. So right now we have two hosts in our cluster, so we can tolerate a failure of one ESXi host. Now define host failover capacity by. So there are many ways where we can go ahead and define the failover capacity. We can go ahead and make use of a slot size, which is just simply the number of powered on VM. We can go ahead and do cluster resource percentage, or we can have a dedicated failover host. So that means it's just simply like a 1:1. In this case, we will go ahead and work with our slot size. That's easy to demonstrate. If you recall, we have two VMs which are powered on VM3 and VM5. So we will be using those two VMs. So now let's just change the capacity instead of the percentage to the slot policy. When we go ahead and click on the slot policy, there are a couple more options being shown here. So if you read this line, it says the slot size is defined as the memory and CPU reservation that satisfy the reservation requirement for any powered on virtual machine in the cluster. So this is really talks about the reservation that we go ahead and assign to the VM. If you recall, when we had created these VMs, we had not configured any reservations. So let's just simply go ahead and hit OK on this page. And that would just simply go ahead and enable the admission control. And now we can come back to the cluster. Within the cluster, let's go back to the monitor tab one more time. Within the monitor tab, if we go to the vSphere HA, now let's just simply go back to the summary tab. If I go ahead and refresh the summary tab, within the summary tab, if you go ahead and scroll down, remember at the bottom we had some of the information. Now if you take a look here, we have something called a slot size. So right now for the slot size, it says, okay, hey, the 32 megahertz and 35 MB. That means this is the amount of the CPU and memory utilization the cluster sees. while the total slot in the cluster is 3052. That means based on this slot size, we can have 3052 VMs be brought up. And right now, 2 slots are being used. Available slots are 1524 and failover slots are 1526. Total powered on virtual machine in a cluster are 2. Host in this clusters are 2, and the good host in clusters are also 2. That's what it shows, the number of available slots and other things, because we had just changed the admission control from percentage into the slot size. Now just remember the slot size here 32 megahertz and 35 MB. Now let's go to one of our VM. Let's go to VM number 5 in this case, and now let's go ahead and simply do an edit setting on this VM. So within the edit setting, we will go ahead and change some of the reservation for this VM. So if I go back and expand my CPU right now, we had not done any reservation for our CPU or memory for any of the VMs that we had applied. So now let's go ahead and configure some CPU reservation for this particular host. So let's go ahead and configure a reservation of maybe 512 megahertz. That should be enough to demonstrate some of the things. And then simply go ahead and hit OK here. Now once the changes are applied, now we can go back to the host and cluster again. Now let's go back to the my cluster. We go back to the vSphere HA again, and within the summary tab, let me go ahead and just refresh this one. If you notice, the slot size was just changed from 32 to 512 megahertz, because that's the minimum reservation that the cluster sees, and based on that, number of the slot size were recalculated. Now based on this reservation, the total slot in this clusters are 190, while 2 are being used. That means for failover we have 95 available, and available are 93. So that's how you can see when you change the CPU and memory reservation, it really impacts your slot size. Now let's go ahead and reconfigure our cluster to really say, okay, hey, for the admission control, this is the slot size that we want to use. That means a 512 megahertz of a CPU and a 35 MB of memory. So doing that is again pretty straightforward. We can just simply go back to the settings, which is again nothing but the configure vSphere availability, and just simply go ahead and hit edit here. And then we can go to the admission control on the left hand side of our pane. So now click on the admission control. Within the admission control, we had selected the slot size. Now we can go ahead and specify a fixed slot size. That means we are fixing the size of our slot, and as you can see, the system automatically reads, okay, hey, the CPU slot size is a 512 megahertz. And again, if we need to change this value, we can certainly go ahead and do that. So now let's go ahead and try making some different change. So the slot size, let's go ahead and reduce the slot size. We know that the CPU that we had allocated in terms of reservation was 512. Now let me go ahead and change this to maybe some lower value. Let's go ahead and probably change it to maybe 400 megahertz. And once that is done, just simply go ahead and do a calculate here. If I go ahead and calculate here, it says, okay, hey, VMs requires multiple slot. If I go ahead and click on view, this particular VM says would need at least 2 slots. The reason, because now we are saying, okay, hey, the slot size is 400 megahertz, but the reservation on that VM is 512. So one slot will not suffice the need for this VM. So that's the reason that says, okay, hey, this particular VM would need 2 slots for it to be fully up and running. And hopefully you get the idea why we need 2 slot size, because the CPU slot size we are saying is 400. Now let's just go ahead and simply click OK here. That would go ahead and close some of the things. Now if we go back again to our cluster and we go back to the monitor, let's go back to the cluster quickly. Let's go back to the monitor vSphere, and let me just go ahead and refresh this one. If we go ahead and refresh this information, we can go ahead and take a look again. The slot size just was changed to 400 megahertz. The memory is 35 MB, but now the total slot in cluster was just got increased. Right now they are 244. So that's how we can go ahead and make a change in terms of the slot size and some of the other settings. Again, we can change the admission control, admission from one type to the another type. Let's go ahead and try doing that. Let's go to the configure under vSphere availability. Let's just simply go ahead and edit these options. And within the admission control, there are a couple of options. Define the host failover capacity by. Now we can go ahead and just simply say, okay, hey, we don't need any more the slot. Probably we can say dedicated failover host, or I can just simply go ahead and say, okay, hey, cover all powered on virtual machine. I'm no more interested in the fixed slot size. I'm interested in covering all of my powered on virtual machines. And we can go ahead and change this from the slot size. Now let's go ahead and simply click OK and then see what happens. So now come back here, the changes were applied. If we go back to the monitor tab one more time, now you can see the slot size are being reflected again. And now let's come back to our virtual machine, the one we had done the reservation. We can just simply take off the reservation. So hopefully you get the idea why we did a reservation, just to really demonstrate the capability in terms of the slot size really. So let's go ahead and simply go ahead and hit OK here. And now we don't have a reservation anymore. So now if I go back and refresh some of the things, it would just take maybe a few more seconds, and you can see the value was just change of the slot again from 512 to 32 megahertz. And using this admission control and some of these policies, we can really go ahead and configure the slot size and configure our failover capacity. And again, we can have admission control to be really imposed, or put some conditions based on the resource usage. That means we have always enough resources available in a cluster if a failover happens. Again, we can go back to the cluster summary tab and we can take a look at some of the information in terms of the resource reservation. Okay, hey, the CPU, memory, and some of the other things can be looked up. Again, we can go ahead and increase the memory reservation, CPU reservation in a particular cluster, and go ahead and play around with some of these settings. And if a failure happens, depending, hopefully we have enough capacity in terms of memory and CPU, HA will succeed actually. So do remember and do pay attention or work with some of these settings, and go ahead and explore. Try working with the percentage in terms of the admission control. This is one of a very important area of the HA when you are working in a production environment. Having a correct admission control really plays a critical role. How good is your HA environment? You can either make use of the slot size, or you can have 1-to-1 ratio of dedicated ESXi host. In case one host fail, you have another host that can go ahead and take care some of the things for you. So that'll be all for this lab. I will see you guys in the next lab.